Okay, so this is for worksheet number 5. Right? Okay, so this is the question that I will discuss, which is 1, 2, up to 7. Except for question number 3. Right. So for question number 1, okay, given the equation is this, and you have to find by implicit differentiation. Okay. So the first thing first is we have to differentiate both sides. So to write differentiate both sides, it looks like this, d over dx. Okay, what is our y? Our y is this function. Okay, bukannya dy over dx and then you write down all this. Nanti you confuse where is your y. Okay, secant hyperbolic x square y equals to d over dx 0. Okay, then you have to find what is the derivative of up sign. So up sign is 1 over 1 minus u. Okay, 1 over square root of 1 minus u square. So this is your u. Okay, x square y square. Okay, and then don't forget that you have to differentiate the inner function x square y. Okay, and then okay, to make it simpler, okay, I will move this one, secant hyperbolic ni to the right. Boleh tak? Tak apalah, later. Ataupun kita buat sekarang. Okay, this one, I put this on the right side. Okay, so dia akan jadi secant hyperbolic x square y. Okay, so now I will differentiate secant hyperbolic. So differentiate secant hyperbolic, you will get negative secant hyperbolic tangent hyperbolic. Tangent hyperbolic x square y. Okay, and then differentiate the inner function x square y. Okay, so now here if I expand, I get x to the power 4 y square. Okay, and then differentiate x square y. Okay, you will get apa? So remember, this is a product of two functions, okay, u and v. Okay, so we can use the product rule. So u v prime, so x square dy dx plus v u prime. Okay, so u prime is 2x y. Okay, so this one would remain negative secant hyperbolic and then tangent hyperbolic. So the same as this one, x square dy dx plus 2xy. Okay, so now we just want to find our dy dx. Okay, so if we expand this, okay, so the first term, dia akan dapat dy over dx, okay, x square over square root of 1 x to the power 4 y square. Okay, and then the second one, you will get 2xy over 1 minus this. Then for the left hand side, the right hand side, you akan dapat your dy dx, okay, x square secant hyperbolic tangent hyperbolic, okay, and then plus with 2xy. So saya tulis kat bawah. Okay, plus minus 2xy secant hyperbolic x square y tangent hyperbolic x square y. Okay, so now let's just combine the dy dx. So our dy dx will be this one, okay, x square over this, okay, minus. Jadi plus lah kan? Plus, so I move this to the right hand side. x square secant hyperbolic x square y tangent hyperbolic x square y. Okay, and then equals to the left hand side. Okay, so I get negative 2xy secant hyperbolic of x square y tangent hyperbolic x square akan jadi plus lah kan? 1 over 1 minus x. Okay. Okay, so now we can simplify this. So dy dx will be equals to, so I move all this to the right hand side. So dy over dx, this one negative 2xy secant hyperbolic x square y tangent hyperbolic x square y by, okay, so you notice here that we have the same kind x square. So I will factor x square out. Okay, and this one would be, so I start with this one, secant hyperbolic x square y, then hyperbolic x square y, and then the second one is plus with 1 over 1 minus x to the power of 4 y square. So you notice that we can, okay, cancel these two. Okay, so what we can get is just negative 2y over x. Okay, so dy dx equals to negative 2y over x. Okay? Alright. Semua dapat? Got it? Cara lain lah, tak apa. As long as the final answer you get negative 2y over x. Kan? KN dapat sama kan? Boleh lah. Okay, next question. Evaluate cos hyperbolic sin hyperbolic square plus 4 sin hyperbolic x plus 2. Okay, you notice here we have two different functions. Okay, remember for integration, the first technique you need to consider is, yes, use substitution. Okay, kalau you tengok kat sini, we can use substitution if we lack, okay, function that is in the denominator so that we can replace the derivative for the numerator. Okay, so if we let u equals to sin hyperbolic x, you akan dapat your du would be cos hyperbolic x dx. Okay, where you can represent this as your du. Okay, so now your integration become du over, so your sin hyperbolic is u square, okay, plus 4u plus 2. Okay, can we factorize this? We have quadratic here. Kan, quadratic ni kan? Can we factorize? No. Tak boleh. It cannot be u plus 2 square. Because when we expand, you should get u square plus 4u plus 4. Okay, but this one is plus. Yes. Okay, so how can we simplify this? Yes, okay. So we can use completing the square. Okay, completing the square. So now, our u square plus 4u plus 2 will be u square plus 4u plus 4 over 2 square minus 4 over 2 square plus 2. Okay, so we can simplify this 3. So you get u plus 2 square. Okay, and then minus 4 plus 2 minus 2. Okay, so now our integration become du over u plus 2 square minus 2. Okay, so what if, okay, I left u plus 2 ni as v, for example. Okay, so my du would be equals to dv kan? Okay, so now it becomes dv over v square minus 2. So it's now we have here is square. kat bawah, there's no V on the numerator. So remember, please refer to the formula. Okay, V square minus constant. For integration, there's no square root. Okay, our V square is positive. So it cannot be inverse hyperbolic. Inverse trigo boleh tak? Tak boleh. Sekejap. Inverse trigo. Inverse hyperbolic. Tak boleh juga. Betul kan saya kira ni? 2 divide 4 by 2, 2. 4. Minus 4 plus 2 minus 2. Okay, sekarang ni salah. So, V minus 2. V minus 2. V minus 2. Alamak, macam mana ni? Oh, yes. Adalah kat sini. Thank you. Okay, so we can use this one. 1 over u square minus a square. Sorry, a square minus u square. So, if we factorize minus, you akan dapat u square minus a square, which is the same as our function here. Okay, so here, kalau we put, we factorize minus, you akan dapat 2 plus, sorry, 2 minus b square. Minus b square. Okay, so which is in the same form as this. Okay, now it's the same. The bagi any condition, okay, so it can be any answer lah, right? Can be either arctangent hyperbolic or arccotangent hyperbolic. Okay, so I choose this one. Okay, so our A is given as, our A square is given as 2. So A would be square root of 2. Okay, so minus 1 over sec 2 arctangent hyperbolic of V over square root of 2. Okay. So, given your V is, so saya sambung kat sini Okay, given your V is negative 1 over sec 2 arctangent hyperbolic of, your V is given as this, U plus 2 of sec 2 plus C. Okay, given your U is sine hyperbolic of X. Okay, so this one would be sine hyperbolic. Yes, it is an improper. Why? Because of this. Okay, dx. So first transform this into proper integral. Okay, from t up to 1, t is approaching negative infinity. X over x squared plus 1 to the power of 3 dx. Okay, so now Let's solve for first. Okay, so integration of x over x squared plus 1. How can we solve this? How? Yes. Okay, remember. Check dulu boleh guna substitution or not. Okay, so what should we substitute? Yeah, x squared plus 1 is easy. Okay, so du will be 2x. 2x. Okay, so your du over 2 will be x dx. Okay, so now it will be du over 2 over u cube. Okay, so 1 over 2 u cube is u to the power of -3. So this is just a normal integration. Okay, so you get 1 over 2 u to the power of -2 over -2. Okay, so u is given as this. So -1 over 4. Your u is x squared plus 1. And then square. Okay, now we have solved this integration. Okay, so we can just substitute into the improper. Okay, so given the, so I approach to negative infinity. Okay, so 1 over x squared plus 1 square. Okay, given t to 1. Okay, so now just substitute, you get 1 plus 1 minus 1 over t square plus 1 square. Right, so here we still have to write the limit t approach to negative infinity. Okay, so now 1 over 1 plus 1 is 2, 1 over 4 minus with 1 over infinity. Okay, 1 over infinity is 0. Okay, so you get your answer is -1 over 16. Kan? Okay, so -1 over 16, converge or diverge? Yes, converge. Okay, let's say the final answer is 0. Is it converge or diverge? Converge. Okay, diverge if only infinity or negative infinity. This is diverge. But converge can get 0, -1, 1 and so on. This is converge. Okay, converge maksudnya the area under the curve is 0 lah. There's no area. Tak ada area. Still converge lah. Right? Okay. This one, find the first three non-zero terms of the power expansion. Okay, so meaning that for this case, you have to use all the 4 steps. Okay, equals to the power series. A0 plus A1x plus A2x square, A3 x cube. So you need to find 3 non-zero. So since the first one will be 0, right? So 1, 2, 3. So you can stop up until x cube lah. Alright. Then you find the derivative. Okay. And then let x equals to 0. And then substitute back into this. Okay. So once you get the series, you can just substitute back into this integral. Okay. And find the value. Okay. Yang ni saya tak perlu bagi jawapan Alright. You ada kelas ke after ni? You have class at 12. Okay, last one Okay, so use ratio test. So remember ratio test, rho equals to limit of an plus 1 over an and approach to infinity. Okay, so you have to find the an plus 1. Okay, so just replace your n with plus 1. Okay, and then copy back the rest and then you akan dapat n plus 1 plus 1. Okay, so here would be 5n factorial over en plus 2. Okay, so your an will be just your original question. Okay, alright. So then to write the row, to find the row, it will be limit of n approach to infinity. So your an plus 1 is this one, en plus 2. Okay, multiply with, so this one just vice versa ni, kita balikkan dia. So you get en plus 1 over 5n minus 1 factorial. Okay, so n factorial equals to n times n minus 1 times n minus 2 and so on. Okay, n minus 1 factorial is n minus 1, n minus 2, 10. Okay, so we can cancel these two. Okay, so what is left is just n. Okay, limit of 5n over. Okay, so this one e to the power of n times with e. This one e to the power of n times with e square. Okay, yang ni dah cancel kan? Oh, 5 pun boleh cancel. Okay, so what is left is just en pun boleh cancel. So you get n times with e je lah. Betul? Yes, n over e. Okay, and approach to infinity. Okay, so infinity over e, you get infinity. So it is diverge kan? Alright, so that is for ratio test. Okay, the last one, divergence test. Okay, this one is very simple kan? Divergence test, you just transform this into limit. Okay, so you write it as limit of n approach to infinity. Okay, so 3n over 5n square minus 1. Okay, then you get infinity over infinity. So you have to apply the L'Hopital's rule. Okay, so you get 3 over 10n. Okay, here you get 3 over infinity, which is 0. Okay, so 0 meaning that diverge tak? Diverge. Okay. Are you sure? Not diverge kan? Okay, so that's it. Okay, forward.